All right, you guys, it is Monday, and I'm going to go ahead and record this. Maybe you've already looked at this before a Zoom or after a Zoom, but let's go through this. So 10, 5, 20. So what we're doing is factoring. So we're doing polynomial factoring. So I keep talking about factoring, so I thought, gosh, why don't I just give them an easy example of what factoring is? So, for example, super easy factoring. So, for example, I know that 4 and 5 are both factors of 20, right? Because they both divide in evenly. And we can rewrite as 4 times 5, which is equal to 20, right? So we're doing the same thing except for with polynomials. So we're basically trying to find factors of these polynomials. So we can have something times something. So first of all, we are going to take a look at our cubic ones. So let's look at our sum of cubes, which is going to be, and I'm going to use a different color so you can see this. How about my pink? Sure. Sum of cubes, if I have a cubed plus b cubed, and this is in your book, it's going to be an a plus b times an a squared minus ab plus b squared, okay? And this should be in your journal, in your book, okay? And then the other, and I'll put it up here, so I have them. So I have them close, is the difference of cubes, okay? That's sum of cubes, and so the difference of cubes. If I start off with a cubed minus b cubed, so if there's a subtraction like this example here, then the only difference is the signs will be different. It's going to be minus plus plus, but you'll see the only difference is the signs. So I'm going to go at a minus b times an a squared plus an ab plus a b squared. Okay, so that's the only difference. And again, this is found in your journal. So let's take a look at the first example. Okay. If I look at example 1, what I notice is possibly some cubes. So I have to rewrite it. I really have to make it look like a cubed minus a cube. So I know that 8 is 2 times 2 times 2. So I'm going to rewrite this as a 2x cubed minus, and I know 125 is 5 times 5 times 5, or 5 cubed. All right, if I know that, then I'm simply going to let the 2x be the a and the 5 be the b. So I will plug them into my formula. So my formula is going to go, okay, a plus b, so I'm going to go a plus b, which is 2x plus 5. I'm using, oh, wrong formula. Dang it. My bad. There's one mistake already today. I gotta use this formula, don't I? Because of the subtraction right there. So I go 2x minus 5 times, I'm going to go a squared, so I'm going to go 2x squared, which is going to be a 4. You okay with 4x squared, because I have to square the 2. Then I go plus ab. So to go plus ab, I'm going to go 2x times 5, which is going to give me a positive 10x. And then plus b squared, if b is 5, so over here I'll just, a was 2x and b was 5. So b squared is positive 25. And that's all I can do. That's it. We're done. This does not factor. Again, if it did, we'd have a different formula. So done. Okay. Okay, let's look at the next one. And again, we're going to keep working on these because these are hard. So when I look at example 2, I'm thinking to myself, what can I do? Well, I believe in this thing. Always common factor first. Let me write that down. Always common factor first, if you can. Always common factor first, if you can. And there's a lot of problems you can't, okay? For example, you can't common factor here. There's nothing in common. But in example 2, I have a common x. So take out the x, common factor out the x. I'm taking an x out of each term, so then I have an x squared plus an x minus 2. Okay, common factored out an x. I could always bring it back in if you want to double check it. But I'm going to put a 1 here to make this easier. I can factor again. I can factor again. Factor again. I notice x makes my x squared, and I'm going to use a positive 2, negative 1. Positive 2, negative 1, because that will give me a middle term of a positive 1x. Okay? All right, awesome. Example 3. Well, let's see. I think I'm going to do this one like a trinomial. I'm going to go x squared, because x squared times x squared makes x to the 4th. And I think I'm going to use multiples of 4, but I'm going to use 1 and 4. 1 and 4, because 1 and 4 will make a 5, but I'm going to use a negative 1 and a negative 4, okay? Because negative 1 times negative 4 makes a positive 4, but when I add them I get the double smiley. Negative 4x minus 1x squared. Negative 4x squared minus 1x squared gives me my negative 5x. But what I notice is that I can do it again. Again, the same trick. I'm going to go ahead and factor. How about x plus 1, x minus 1? Difference of squares. And how about x plus 2, x minus 2? Because that would multiply to make the x squared minus 4. Okay? So I'm going to factor as far as I can on these, okay? All right, awesome. That's as far as you can go. All right, number 4. We did these last year in geometry, but you might not have remembered. So if I see 4 terms, we're going to try grouping. 4 terms, we're going to try grouping. So when you group, I'm going to put these two, the first 2 together. All right, I'm going to put the first 2 together, and I'm going to put the second 2 together, okay? I might put a 1 here. Might be useful to make that a 1x. Might be useful. I'm kind of thinking it'll be useful. Maybe. Maybe not. I don't know. Okay, so let's take a look at the first group. What do they have in common? Well, they've got an x squared, don't they? So if I take out the x squared out of the first 2, just the first 2, ignore the next, just look at those 2, okay? Out of the first 2. So if I take it out of the first 2, x squared, I'm going to have an x minus 2 left over. And then I'm going to look at the other 2. So if I look at the other 2, what do they have in common? Well, nothing. They don't have anything in common except for maybe 1. But I need to make it look like this, so I'm going to factor out a negative 1. Let's see how that's going to help, okay? Let's see how taking out a negative 1 is going to help. So if I take out a negative 1, I'll have an x. And I took a negative 1 out of 2, which makes it a negative 2. Now, if you don't see that, you can always go back and multiply negative 1 times negative 2, okay? And that will give you your positive 2. So, when we did grouping, the next step we did was we factored again. We recognized that they both have an x minus 2 in common. So I'm going to common factor out that x minus 2. So I take it out of both. And so what I like to do, so I don't get confused, if I've taken it out, I have to cross it out, okay? I just like to cross it out so I don't get confused. I'm taking it out, put it right there, okay? Now, what's left over is an x squared minus 1. Okay, I see something else. I see something else. There's more that can be factored. So I'm going to go x minus 2, and then this will factor into an x plus 1, x minus 1. Well, that's a bad looking 1. Sorry, you guys. Sloppy, sloppy, sloppy. And that is the end of that. X plus 1. So it's x minus 2, x plus 1. Oh, that's a terrible one. And then x minus 1. Okay, these are hard, but that's why we're going to keep working together to get them done. Okay? All right, next page. Let's see what else I have. All right. Whew, looks hard, but it's not. Looks hard, but it's not. So what I see is, oh, wait a minute. Hold on. Always common factor first. Always common factor first. So, yeah. I think I see a common 2. And I see they both have at least 6 x's, or x to the 6th in common, okay? So if I common factor out a multiple 2 and a common x to the 6, I'll be left with an x to the 3rd minus 8. That can be factored again. We're going to use this formula. We're going to use this formula because it really is the same thing as x cubed minus 2 cubed, because the 8 can be rewritten as a 2 cubed. So I really do have a cube minus a cube, okay? So my formula was, if I have a cubed minus b cubed, my formula was a minus b times a squared plus ab plus b squared. Again, we already wrote that down. It's already in our notes. It's already in our book. But let's see how we can use this, okay? So the 2x is just going to be there. I can't do anything with 2x. Let's just write the 2x to the 6 down. It's finished, okay? I factored it out. But there's more factoring that can be done. So I want to factor the next piece. I got a cubed minus a cubed. I'm going to use this formula. So I'm going to let a equal x, because x cubed, and I'll let b equal 2, because 2 cubed, okay? And then I'm just going to put these values into my formula. All right, so my answer is going to be a minus b. Well, that's going to be x minus 2 times a squared. Well, that's going to be, a is x, so x squared plus ab. Well, that's going to be 2 times x, or plus 2x, plus b squared, or 2 squared, which is 4. And that is my completely factored answer. Okay? Yeah, these are hard. That's why I'm going to help you with these. Okay? I'm going to help you with the homework as well. Okay, 6. Slide it up. Okay, next. Oh, wait a minute. Always common factor first. Always common factor first. So I'm going to do that. I see a multiple of 2, and I see at least 4 x's, x to the 4th, in common. They all have at least a multiple of 2 and a multiple of x to the 4th in common. Okay, so if I common factor out x to the 4th, what's left over? X squared minus 13x plus 41, right? 42. Duh, 42. Hey, I think that'll factor again, because I 6 and 7. 6 times 7 makes 42, and 6 plus 7 makes it 13. So let's just do it. So keeping the 2x to the 4th out, because it's done. It's done, so we have to keep it. And then x minus 7 minus 6. Negative 7 times negative 6 is positive 42. And if I add the 2, double smiley, negative 6x minus 7x gives me my negative 13x. Okay? There it is. All right. Last but not least, we're going to talk about synthetic substitution more. Now, I haven't talked a lot about it, but I want to talk about it now. Synthetic substitution. So I could divide x plus 1 into x cubed minus 13x minus 12. I could do that. And then what I'm looking for is the remainder. Okay, so I'll stop for a second and let you catch up, okay? Well, if it's a factor, all I care about is the remainder. The question doesn't say divide. Just says, is it a factor? So all I care about is the remainder. So if I plug in, if I take my x plus 1, set it equal to 0, and I solve, and I get x equals negative 1. If I plug negative 1 in, I'll get the remainder. So I'm going to take negative 1, and I'm going to plug it in. So I'm going to go, okay, negative 1 cubed minus 13 times negative 1 times negative 12, and what I get will be the remainder. I really will. What I get will be the remainder. There's a reason for it, because it's actually a point somewhere on the graph. If it's 0, then we know it goes on the x-axis. So anyway, negative 1 cubed is negative 1, Negative 13 times negative 1 is a positive 13 minus 12. Sure enough, I get 0. Okay, so this tells me it goes in evenly, that x plus 1 is a factor of x cubed minus 13x minus 12, because if it goes in evenly and you get a remainder of 0, it is a factor. Okay, that's what I have for homework today, or for lesson today. The homework will be up on Canvas, so check it out and we'll go through last night's homework together.